All right, so next up we talked about acceleration. So we did this first, then we went to acceleration. Acceleration had three formulas. We talked about two specifically. That was d is equal to 1/2 at squared plus vit plus the initial distance. Most of the time you don't need that initial distance, but just in case you start at a certain height and you're moving from there, you may want to include it. Oftentimes though, this will be 0. And then we had a is equal to vf minus vi over t. And then we lastly had this formula that we didn't use often, but I'll explain why or when it should be used. So this first formula was for finding the displacement, or the distance something traveled. It had the t in it. The t is often how you would find the time that it took to get somewhere. So like, for instance, if something starts off with an initial velocity of 0, and you know that it goes 5 meters, and you know its acceleration is 3, right? The only unknown would be the time. So you could find how long it took to get to a location. So acceleration equals vf minus vi over t. That was another way to find the time. If you knew the acceleration and you knew the final and initial velocity, you could solve for t. Let's just say that you didn't know time and another variable. So you knew everything but time and, say, distance. Well, if you didn't know, for instance, if you didn't know the time, sometimes it was easier to use this formula rather than trying to find out one of the variables using one of these two other formulas. So you could use this formula. Oftentimes it comes in handy if you don't know the time or the final velocity. So if you don't know the time or the final velocity, this vf squared equals vi squared plus 2ad, that comes in handy because if you don't know the final velocity, or if you don't know the initial velocity, you have to do a quadratic formula to find the time, right? So like, let's say that you know that acceleration is 5 and initial velocity is 5. You know the distance is 3, but you have to find a time, right? It would be really difficult because you would have to find a quadratic formula, but you might be able to plug it in this formula and avoid having to do that. Quadratic formulas are often where people slip up because there's two answers. So if you if you don't know which one it is, you could screw up. All right, so that's the main things with acceleration. Another main thing with acceleration is people tend to associate this number with the acceleration all the time. G is equal to 10 meters per second squared. It is not the acceleration for everything. All right. I noticed that whenever we took the test, I noticed that there was a lot of us that just kind of plugged it in the hopes that that was the acceleration. The only time that's the acceleration is if an object is in free fall. If an object is not in free fall, it does not have that acceleration. So this is only for free fall. Okay? Only for free fall. In addition, there's three graphs associated with this. There's the distance versus time, the velocity versus time, and the acceleration versus time graphs. Distance versus time, when something's accelerating, will be curved. Velocity versus time will be a straight line, and acceleration versus time will be horizontal. In the velocity versus time graph, the slope is equal to the acceleration of that object. And the area under the curve, what does that represent? The distance of that object. And remember that regardless of how the velocity versus time is shaped, you can always find the area under the curve will be the distance, regardless of how it's shaped. It doesn't necessarily matter. All right? Anybody got any questions over acceleration? Okay.